Yeah, all right. Hi, and good morning, everybody, and welcome to this next talk. So before we start, I just want to say that I really love NGDE. It's my third appearance here at the third edition of this conference, and it's really great. The thing that I try to contribute to this conference is the thing that our clients ask for and recent trends in software development. So in 2019, we talked about Angular performance when our clients hit the limits of what Zone.js could do. And as you've heard, there's a path forward now. And in 2022, we talked about the great new capabilities that are enabled by Project Fugu that make your web application like even better and even more capable than it was possible before. And this year, I want to talk about another interesting thing. It's a trending topic, and we will see beta versions of Chrome again. And we are talking about AI in the browser, or how you can make your Angular app smarter by using APIs like WebGPU and WebNN, but also the new prompt API that's currently in implementation by Chromium-based browsers. So I guess it's no surprise, and every one of you knows it, generative AI is everywhere, right? You see it when you scroll down your Twitter or Instagram timeline. It's what basically every other ad tells you on the web, right? Generative AI is here. Some more examples are Apple Intelligence, right? It's glow time with the new iPhones. There is generative fill in Adobe Photoshop, where you no longer need to spend a long time to do basic image editing. Now the AI can do it for you. It can replace objects by just a prompt. And there's the assistant-style AI applications like Microsoft Copilot, let's say, that's built right into the operating system and lets you change settings and so on and so forth. And today the question is, can we add capabilities of generative AI to our Angular application? And the answer obviously is yes. And there's a spectrum of things that you could do. Today I want to talk primarily about generative AI, and that's artificial intelligence that basically generates something. So it typically does it's creating an image, it's writing text for you, but it can also understand text, and it can detect objects in images, for example. Stuff that you could do, and this list is not exclusive, is dealing with text, with well-known models like the GPT models or Mistral and so on. Image generation and processing with models like DALL-E or Stable Diffusion. You can generate audio and music. So in Germany, there are some songs on the charts, right, which were generated by AI. And then there's the speech-based models who can create speech out of text and create text out of speech and so on. And that's, again, not it. There's also many advancements in video, let's say editing and video creation, that are also super interesting. Today I want to focus on the first two, so on text generation and processing, and on image generation and detection of stuff in images. So, the first thing that you would normally do if you build an AI-based application is to go to a cloud provider. And there are many of them. There is OpenAI, there's the Azure OpenAI version, so to say. There is Grok, which has a stunning inference speed of over 1,000 tokens per second, or the Google Cloud, plus many, many more vendors that you could use. And that's also what we did. So the first AI application that we built is an Angular application. Wow, big surprise, right? That shows a nice example of generative AI beyond this chat-style app, right? What it does is it's a smart form filler. It uses your normal Angular reactive form in that case, and then allows you to enter the data in a natural way. So instead of filling in the blanks and the form fields, all you do is you use your voice. So we combine a speech model and an LLM that is then capable of filling in the blanks in this form. So let me switch to that example. It is here. So imagine you have a car and it needs to be repaired. And now the thing is that the person who inspects your car goes around the car typically, right? And then has a look at different things, like the tread depth, for example, of your tires and so on. And it would be pretty hard if they would have to carry their notebook around and then type in that stuff, right? So the idea is they can just use their voice, right? So they just record what they see, and then in the end, we are going to fill in this very complex form, as you can see. So I'm just testing it, see if it works, because it broke like an hour before I gave this talk, and it does. Great, awesome. All right, now let's try this. And the cool thing about LLMs is that they understand like plenty of languages, not just English. So I will also try to sprinkle in some German for you here. So let's see. Yesterday, I investigated a VW Golf 6 with the license plate GERCL123. It has a mileage of 30,000 kilometers. 60,000 kilometers. It has winter tires, and the tread depth is 7 millimeters all around, except on the rear right, there's 6 millimeters. Und es gibt einen Steinschlag in der Windschutzscheibe, der einen Riss verursacht hat. All right, now let's see what happens when we stop that and see the recognition. So I talked about an investigation yesterday. The LLM is aware of which day it is today. So today is the 10th of October. You can double check it on your watch, right? So the date is yesterday. Make is correct, model is correct. License plate is almost correct. Mileage, I corrected myself, right? I said 30,000 kilometers first and then corrected myself, so that is correct. I think I said winter tires. Yes, right. I said the tread depth is like 7 millimeters except for the rear right where it's 6. And then in German I said there's a stone chip in the windshield with a cracking, right? So basically it filled in all blanks correctly. And it's awesome because we didn't have to fill it in ourselves. And that's a cool use case of LLMs, data extraction. That's one thing where they are pretty good at. And yeah, it's great to see that we can embed that so easily. This demo used a cloud service. It used Grok, because as you might have seen, like inference was super fast. It took, I think, not even a second to infer and to extract the data from the input. However, when you're using cloud services, there are certain drawbacks. And these are that, for example, you need a stable internet connection. You may not always have that. Then it's subject to network latency and server availability. Especially in the early days of ChatGPT, you could run into this like, sorry, we are out of capacity error message screen, right? And then you transfer that data to a cloud service. So it may be fine for your car, but it may be not fine for your, let's say, medical status, right? Or other personally identifiable information. And typically it requires a subscription, so you have to pay for that. So the question is, can we maybe get around those drawbacks? Can we run Gen AI models locally? And the answer is, yes, we can. And I want to show you how today. And I want to start with the text-based approaches, and therefore we will use so-called large language models. Large stands for that they are trained on lots of data. Language stands for that they process and generate text, so in a natural language. And model stands for, well, the neural network. In the end, it's a program that can run on your machine. And there are plenty of well-known examples, like the GPT model series by OpenAI. There's like the Gemini or Gamma models of Google. There's Llama by Meta AI, and this list, again, is not exclusive. And there's a lot of innovation happening, and every other week there's a new model that claims to be better than the others, and the context sizes are improving, and so on and so on. So it's really a trending, bleeding-edge topic, and it's constantly improving. Think about where ChatGPT was 1 year ago. It is a total surprise also to me how far this field evolves. However, there's also a problem, and that is that large language models are not only large because they are trained on lots of data, it's also that they are quite large in size. So here's a comparison of differently sized models. The bigger the model, the more parameters it has, the better quality of the responses you typically get. Of course, it It varies, but overall, that's what it is. And so if we want to use like a very good model, like let's say Llama 3 model here at the bottom, that would be 40 gigabytes in size. And it's pretty hard to download that. That sheer amount of data, right, when you're on a mobile plan and when you're visiting a site for the first time. So that's probably not feasible. On the other hand, like the model at the top, or the models at the top with like 3 billion parameters, they don't produce the quality that we want. So the question is if there's like a sweet spot between like model size and quality. If you want to add a large language model to your Angular app, there are different options that you can use. And the first one is WebLLM. That's basically a clone of ChatGPT that runs right in your browser. And it uses different APIs like WebAssembly and WebGPU. We will talk about that in a bit. But first of all, let's have a quick look at this project. So I'm switching back to Chrome here. That's the stable version of Chrome right now also. So it will also work on your machine. And here is the WebLLM chat. And what should I say? It works as you expected. So you can ask it stuff. So for example, what are there any interesting things to see in Bonn, for example? So let's see what it says. As I've said, this model is quite large. I've downloaded it before. So I think this model is like 4 gigabytes, maybe more, I don't know. So I downloaded it before, but as you see, it still takes time to pull it from the cache. And now the answer is correct. So Bonn was the former capital of West Germany. That's true. It has a rich history, right? I have no idea about the points of interest here, if they really exist. They sound at least as if you could promise them. So that's pretty nice. And all of that stuff happens right here on this machine. So I could disconnect. Let's actually do it. I could disconnect my Wi-Fi here. And I could now ask it things like convert that list to JSON, for example. And it should still run, right? So Wi-Fi is disabled. And hopefully, it doesn't leave me alone now. Yes, it works, right? And now it prints that list of points of interest in a JSON format. And that's a great thing about large language models. They have like this trivia knowledge. They have like language knowledge. They can translate stuff. We could also ask it to translate that list to German now or whatever language you want. And it also has this like programming knowledge. So it has an idea of what JSON is and how it can convert the data from like the natural language format to JSON. All right, so that's WebLLM. And I will turn on my Wi-Fi again. All right. So the cool thing about WebLLM is that you can simply install it as an npm package. So just npm I mlc-ai/WebLLM is enough for you to actually use it. I also have a demo for you, and we will have a look at that in a second. Before we do that, we need to talk about like the basic concepts of large language models, because they are very interesting when you deal with them for the very first time. The first concept is that it's now prompts that serve as the universal interface for your users, but also for developers like you. And it's pretty uncommon for us developers to specify our requirements and the things that should happen, not as code, not in JavaScript, not in C#, TypeScript, or whatever, but in German, English, or what else, right? The second thing is that this leads to a paradigm shift, because we can do that suddenly. Suddenly, it's natural language. It can be used to do all of that stuff. And of course, it also has its caveats, right? So yes, there is non-determinism in those models, and yes, there are hallucinations, and yes, there's the possibility of prompt injections. That's basically the technology as it is, right? So it has many advantages, as always, and it also comes with certain disadvantages and restrictions. So I built WebLLM into this neat little other Angular forms-based app. It's a to-do list app, right? Standard demo. And then there's like this prompt box at the very bottom. And yeah, let's first of all have a look at how the code looks, and then we will run the demo. So I'm going to switch to my web storm here. And again, it is unusual for us as developers, but basically this is what I say. The box at the bottom should be like a chat assistant for the to-do data that the user entered, right at the top. And now basically we have to instruct the model and define how it should respond, how it should react. And that is done through a natural language prompt. So here I say, hey, you are a helpful assistant. It's like the standard grounding. And here is the user's to-do list. Now, interestingly, I will convert that to-do list to natural language, right? So we have it as a JavaScript object, and now we need to convert it to text. More advanced models also understand JSON, but the smaller models don't, so I just convert it to like a markdown style list. And so I say, hey, that's my title, and then in brackets, this to-do is done or it's not done. And then based on this list, answer the user's question. I think there's an apostrophe missing. And then basically you specify the question. And then it should do the inference. So I have that here as well. Okay, it's in Canary now, right? Because I also have like another API that I want to show. And as you can see, there are 3 standard to-dos. It's wash clothes, wash my car, pet the dog. And now we can ask questions about this data. And as all of this stuff is again handled locally, and as all of my data is part of the prompt, all of that stuff will never leave my system, right? It's not used to train AI models. All of that happens here on my PC. And it's great because you can ask the model whatever you like, right? Without anybody else to know what you're asking for. And now let's ask something. For example, how many open to-dos do I have? The right answer would be 2. We again need to wait for the model to be loaded from the cache. Again, that takes a while. And hopefully it tells us that I have like 2 open to-dos. And it's right. I have 2 open tasks, washing my car, that's right, and petting the dog. Therefore, you have a total of 2 open to-dos. Right. And now you can do all of this stuff that I said before. So convert my list of to-dos to XML, for example. That is also working. So we are running this, again, all happening here on my machine. And now it gives me a great XML-based list of my to-dos. Awesome. We can say translate my to-dos to German. And then it hopefully should give us a great answer here. Waschen von Kleidung is right, Autowaschen is correct, and okay, Hund petten is not exactly right, but well, at least it's sort of okay. Again, this is a smaller scale model. The bigger ones, they are also capable of that stuff. We can do other fun stuff like translate my to-dos to Victorian style English, for example, right? And then see what it does. And the cool thing is that the LLM will just do it. And I don't have to, right? As a developer, you always need to know what the user wants to do. The LLM just does it, right? Whether it's good in it or not. Yeah, okay, so that is, okay, it's Victorian style English, I guess. Right. You see there's no add button, right? So I added like a neat little extra feature. If I add this to the prompt, I can basically instruct the model, if you have a great suggestion, then just put suggest in your answer. And then my code picks that suggestion up and allows me to add that suggestion. That's poor man's tool calling. So there are models that can do that in a much better way, but it's not yet implemented for all of the web-based and local models. So let's save this. Oh, and bring back this line here. And try it again. So suggest, or based on my to-dos, what else could I do? And let's see what it comes up with. Now, sorry, I've changed the code. We have to load the model again. But then maybe we get a nice suggestion. So let's see. OK, I could water the plants. Yeah, go for a walk, read a book, call a friend, cook a meal. All right. And now basically it has collected all of those suggestions, and now I can add them to my to-do list. So I should water the plants, yeah, certainly I should read a book, and so on. Yeah? So all of that stuff is possible with the help of LLMs on your system. right, so how do they do that? So how is it possible to run this on your machine? The first API involved here is the cache API. That basically allows you to store like also lots of data, lots of files on the user's device. So what we do is we are downloading the model from Hugging Face into the cache of your device. However, there's a problem. You all know the same origin policy, so storage is isolated per origin, so Google.com and Google.de cannot share storage. So if they both want to use the model, they have to download it twice, right? So a disadvantage also of this approach. But apart from that, it really works. It's on my machine. I can turn off Wi-Fi and it will simply continue to run. Then they are using WebAssembly. WebAssembly is the bytecode for the web. It's a compilation target for arbitrary language. You can compile C# and Java and whatnot to the web as long as the web supports what you want to do. For example, there's no arbitrary access to the file system. And it can be faster than JavaScript, like in some scenarios, but it is possible. And WebLLM needs a model-specific WebAssembly library to accelerate certain computations that the model needs to do. So WebAssembly is the first important requirement. And the second one is WebGPU. WebGPU is still a bleeding-edge API, I would say, and it grants you, as a developer, low-level access to the graphics processing unit of the device. And it allows you to achieve near-native performance for machine learning applications right on the web, right in your browser. It's currently only supported by Chromium-based browsers on Windows and macOS. I think it's in the technical preview of Safari. There is a sort of implementation in Firefox, but it's not active yet. So that's the current state of this API. And the cool thing is that that's not where it ends. So there's another API currently in specification that is called WebNN. And WebNN stands for the Web Neural Network API. And this API will grant your app not only access to like the CPU and GPU, as you could do before with WebAssembly for the CPU and GPU with WebGPU, but additionally also to the neural processing unit, the NPU, that many devices now ship with. And now, with the help of this API, you can get like super fast and super advanced machine learning applications right on your system. It's currently in specification by the WebML working group. It's a candidate recommendation draft, so it's nearing completion. And it's currently being implemented in Chromium. It's behind the flag, again, bleeding edge, but we will have a look at that right now. And it even has a better performance compared to WebGPU. This chart here basically shows that WebNN can talk to your GPU, GPU, and NPU. All right, now for a little demo. We go back here to Chrome Canary, where I enabled the flag, and we go to the WebNN samples. You see what you can do with this. I promised you some image detection, so we go to the image classification demo. And now we can choose from the different WebNN versions. Let's do like an image detection with CPU-based WebNN detection. And we see that its inference time, to find out that this is a lesser panda, was 26 milliseconds. Now let's do that using the NPU, which is built in the system, in the Apple Silicon chip. Now let's do the same thing. And we see that the inference time is down to 2 milliseconds, right? So significantly faster than it was before, with, I guess, even better results. If we compare that basically to the native execution of web-based machine learning models, we see this. Important are the blue bars here. The light blue bar is the web execution speed, and the dark blue bar is the native execution speed. And at the top, this blue line, which can basically be seen at the axis on the right, shows you the ratio. And as you can see, using WebNN, we achieve like almost, in most cases, way beyond 90% of the native speed. In one case, here for the face mesh V2 model, like only 80%, but it's really like accelerating all of its stuff by far. You've seen that downloading the model takes time. You've seen that initializing it also takes time. So the question is, can we get better at that as well? And the answer again is yes. So what many vendors currently do is ship a a large language model along with their operating system. Apple is doing that with Apple Intelligence on device. Google is doing that with Gemini Nano on Android. And now the idea is, why can't just our browsers ship with a certain machine learning model? And that's exactly what this new experimental API is about. Chrome is experimenting with the built-in AI built-in AI APIs. Microsoft is doing as well. And the idea is we ship your browser with like a Gemini Nano model included. And this allows us to now share the model between origins. So we don't have to download it again. It allows us to directly start the model without waiting for it being loaded from the cache. And it uses the native APIs directly. So it's as fast as it can possibly be. There are many APIs in development. One of them is the translation API that uses the model in the background, which translates content, detects languages in text. And there are the writing assistance APIs that allow you to summarize text, to rewrite text, or to create new text paragraphs. And that is what this set of APIs can do. And I want to show you that in our demo application here. So I can simply switch to the prompt API, and I can now ask the same set of questions. So for example, based on my to-dos, what else can I do? Remember that we needed to wait for the model initialization the last time, but this time it directly starts, right? So there's no waiting. It's directly working, directly running. It supports the suggestion feature, right? So we can wash our car and pet the dog and so on. And this is, again, all built in on this machine. I can switch off the network. It will continue to work like this. Chrome ships with its own version of Gemini Nano. If we go back to this forms completion use case, again, it's a small model, so the quality is not as good as for the cloud-based models. But still, it works, right? So let's try that again, this time with prompt API and with the address form, because the car form would be too complicated for this model. But let's try it with this. Hi, my name is Chris, and I live in Paris, France. And I work for workshops.de. Also, like the speech recognition is done on device, so we could also turn off the network here, and it has correctly parsed my first name, the company is right, the city is right, and the country is right as well. Again, all happening on this device without downloading a model, because the model was simply there when I installed Chrome. All right, so that's the prompt API. Still, if we compare like the execution speed, then we see that like the cloud-based models are much faster, right? So the big red bar is Grok, and like WebLLM is at the very left end of this chart. So again, the cloud-based, server-based models continue to be a little bit faster. Now, I've also promised you image generation, so we also want to have a look at that. So basically implementing generative fill in our Angular app. And there's a solution for that as well. We used the Stable Diffusion model here. It's an open source model created in Germany, in Munich, by the way. It generates 512 by 512 pixel images from a natural language prompt. There's a specialized version of it called WebAssembly, which is 2 GB in size, which works on the web. However, there's no NPM package this time, so we need to basically copy-paste the code in order to run it in our Angular app. And there's a web-based demo as well, so let's use that as well. So I think WebAssembly was here. Again, works in your version of Chrome as you have it. Now we can specify a prompt, a photo of an astronaut riding a horse on. Now let's say something like in front of the Brandenburg Gate, and then see what it does. Again, we need to download the model from the cache. It's 2 GB in size this time, and now it takes a while until it's finished generating this image. We are at step 5, and you can see like the cloud-based approaches are much faster, right? So Adobe Firefly, it would have long been generated, but again, it's all happening on this machine, which is not even connected to 2-power outlet, right? So it's all on battery right now, maybe also throttling a bit, I don't know. But when it's done, we should see, hopefully, an astronaut, riding a horse in the front of the Brandenburg Gate. It's a horse, it's a Brandenburg Gate, and maybe also an astronaut. All right, cool. So pros and cons, what have we seen today? Plus, data doesn't leave the browser. You can ask it whatever you want. Nobody else will see it. Good for privacy. It's highly available. It also works when you're offline, regardless of your latency and so on. It's stable. Again, my demo crashed 1 hour before this talk using the cloud-based model. That's not nice. It cannot happen with local models. And the cost is low because your users pay their execution, right, on their machine. Quality is lower, certainly. There are high system requirements. The model size is large. Models cannot always be shared, depends on the API that you want to use. And the model initialization and inference are relatively slow. Also, all APIs are very experimental. There's a possible escape hatch. There are so-called transformers provided by Hugging Face. These are smaller, specialized models that can do certain stuff, but only that thing. Right? LLMs can do anything. And let's say there's a translation model who can only do translation from language A to B, but therefore it's only 78 megabytes in size. So that's a good alternative solution here. Yeah, there's a JavaScript library for this called Transformers.js. Supports most of the models that are available on Hugging Face, so that's also a nice thing. Now I want to summarize it up. Cloud-based models remain the most powerful models right now. Due to their high system requirements and due to their high size, this generative AI in the browser locally model is probably only interesting for very special scenarios where you have high privacy demands like medical stuff and so on, or definitely the need for offline availability. There are small specialized models as an alternative, Transformers.js. Large language models are becoming more compact and more efficient though, so who knows what the situation will be 1 year from now. Vendors are starting to ship their operating systems and devices with AI models, so they are just there, they are just on the system, and devices are getting more powerful for running AI tasks. Think the AI PC by Intel or Apple Intelligence and so on. So I want to encourage you to experiment with the AI APIs and make your Angular app smarter as well. 36 hours ago, I met Mark Thompson in Brooklyn, New York. I visited the conference, and he said that I should greet all of you from him. So greetings from Mark, and thank you for listening and joining this morning. Thanks.